Hello. Now we'll discuss regarding the design of a knuckle joint. Now, what is the purpose of the knuckle joint? Where the knuckle joint is being used? What are the different components of the knuckle joints are there? And how to design the knuckle joint? Let us see what are the different applications are there. It is being used in the tie rod of the roof trusses, tension link in the bridge structure, link of the roller chain, then tie rod of the jeep crane, and knuckle joint is being also used in tractor and trolley connection. Now let us see. This is a tractor and trolley connection where the knuckle joint is available. If you are seeing the pictorial view for the knuckle joint is visible somewhat like this. Now this knuckle joint will have a different parts will be there: single eye, double eye, this is a knuckle pin, collar, and split pin will be available. Let us say this one in the orthographic projections, that is a fork, it is also called as a double eye end, it is also called as a single eye, this is the knuckle pin, okay, then split pin is there, okay. If you see in orthographic isometric view of that one, this is somewhat like three different parts are available. Now we need to design, we need to evaluate, we need to calculate the dimensions of all these parts. Now let us see, we'll use own designation somewhat like this, nomenclatures, that is D is a rod diameter, small d is a rod diameter, then dp is the diameter of knuckle pin, D is a outside diameter of single eye, this is the outside diameter of single eye, then T is the thickness of a single eye, this is the thickness of a single eye, then T1 is the thickness of double eye, okay, then DH is the diameter of pin head, DH is the diameter of pin head and collar, or this one, then T2 is the thickness of pin head and the collar. Now let us see, let us evaluate the permissible stresses. Sigma T is the permissible tensile stress, sigma C is a permissible compressive stress, sigma T is a permissible tensile stress, sigma C is a permissible compressive stress, and tau is the permissible shear stress. Now by using maximum distortion energy theory of failure, yield compressive strength will be equal to the yield tensile strength, and yield shear strength will be taken as a 0.577 of SYT. It is 0.577 of yield strength in tension. Therefore sigma T permissible will be equal to SYT by Fs. Sigma C permissible will be equal to the yield compressive strength divided by factor of safety. As yield compressive strength and yield tensile strength is same, therefore it will be equal to the SYT by Fs. Then tau permissible will be equal to the yield strength in shear divided by factor of safety. As yield strength in shear is equal to 0.577 of SYT, therefore tau permissible will be equal to the 0.577 of SYT by Fs. Now first of all, we need to calculate the diameter of rod. Now the rod is subjected to the tension. Generally the knuckle joints are being used to use in the tension only. It is not preferred in compressive type of load. Now as it is being subjected to the tension, therefore it will get fell under the tension. Therefore P divided by, this is the section, P divided by pi by 4 d square. That is sigma T is equal to it is the normal stress, that will be force divided by area, that is the P divided by pi by 4 into d square. Therefore d will be calculated as under root of P divided by pi by 4 into sigma T. This is the formulation for the evaluation of diameter of rod. Then let us see next parameter that we to evaluate, that is the diameter of the knuckle pin, that is nothing but your dp, diameter of knuckle pin, that is dp. Now we want to evaluate the knuckle pin is being inserted between single eye and double eye, okay. Knuckle, let us see this diagram. this knuckle pin will be inserted between fork end and eye end, or double eye and single eye, like this. Now this portion may get sheared out. This portion may get sheared out, and as both the ends are being pulling, therefore there may be the bending chances are there. Therefore this knuckle pin will have two different stresses, that is the shear stress and bending stress will be available. Now let us see, first of all we'll use the shear stress. Now how it will get sheared out? This is the force P which is being applied, and it is a shear is available. Now it is being subject to the double shear. Then now what is the diameter? That is pi by 4 into dp square. Therefore 2 into pi by 4 into dp square is the area of shear. Now therefore we will calculate the shear stress, that is P tau will be equal to the P divided by 2 into pi by 4 into dp square. Therefore after simplification you will get the diameter dp is equal to under root of P divided by pi by 2 into tau. Tau permissible, it is equal to the 0.577 of SYT by Fs. Then next one, that is the thickness of a single eye. Now this single eye, as it is being subjected to the tension, it will fail at the weakest section. Now which is the portion which is subject to the weakest section, where the less amount of material is available? That means this is the portion where it is the less amount of material available. This is the weakest section. Now as this is the weaker section is available, okay, what will be the area? This is a tensile stress that will get to fail. Now area of failure is perpendicular to the force, therefore it is a normal stress, that is sigma t is equal to P divided by this much area. How much is this area? Outer diameter minus inner diameter. What is outer diameter? Outer diameter is d, inner diameter is equal to dp. That means d minus dp into the thickness of single eye. What is the thickness of single eye? Thickness of single eye is nothing but your t. Therefore sigma t is equal to P divided by d minus dp into t is the area. Then single eye is also subjected to the shear stress. This is the area of shear. Again it is subjected to the double shear. Area of shear will be d minus dp into this much length. Into this much length. Now how much will be this length? How much will be this length? Now to get sheared out, okay, it has to be the area of shear has to be calculated. Again at this location there will be the crushing will be available. It will also subject to the crushing stress. Now crushing stress is a type of a compressive stress. Now there are two stresses, subset of compressive stress are available. One is the crushing and another is the bearing stress. Now crushing stress, where is no relative movement is available, and in bearing stress or in bearing pressure relative movement is available between the two meeting parts. Now let us see the crushing stress which is available at this location. This area is subject to the crushing stress. This area is subject to the crushing stress. This area is subject to, inside portion is subject to the crushing stress. Now how to calculate the crushing stress? Force divided by projected area. Now what is this projected area? dp into t is the thickness of the single eye. Therefore dp into t is the thickness of single eye, that is nothing but my projected area. Therefore sigma c is equal to P divided by dp into t. Therefore t is equal to P divided by sigma c into p. Now this value of t is also calculated as 1.25 times of d. Then the next one, that is thickness of your double eye, that is also called as a fork end. Single eye is also called as a eye end. Now double eye is also subjected to this double eye. Let us see this diagram. This double eye is subjected to the tensile failure, shear failure and crushing failure as well as in case of a single eye. Now let us see this single eye. This single eye is failure to the, this end is subjected to the crushing failure. Similarly double eye is also subject to the crushing failure. Now there are two eyes are there, two ends are there, therefore the area will be double. What will be the area? Outer diameter minus inner diameter into the thickness. What is the thickness of double I? That is nothing but T1. Therefore, capital D minus small dp into T, it is the projected area of one eye, a single eye, a double eye end. Therefore, there are two eye ends are there. Therefore, 2 into D minus dp into T1 is nothing but a area for crushing area for the double eye. That is 2 into dp into T1 is there. Therefore, T1 will be evaluated P divided by 2 into dp into sigma C. This T1 is also calculated as 0.75 times of D. That is the larger value has to be selected. Then the next one, outside diameter of the single eye. Now how to evaluate the outside diameter of single eye? That is capital D. Now single eye is subject to the tensile stress. Single eye and double eye both are subject to the tensile stress, shear stress and crushing stress. Now we have to use the concept of crushing stress. Now will you use the concept of a tensile stress which is going to occur in case of a single eye. Now this outside diameter can be evaluated by using a tensile failure. Okay, now outside diameter of single eye, how to evaluate? Again it is being subjected to the tensile stress as well as shear stress. Now tensile stress, this is the portion where it is subject to the tensile stress, that is outer diameter force divided by area. Area should be perpendicular to the direction of force P, that is outside diameter minus inside diameter, that is capital D minus dp into T is the thickness of single eye. Then shearing failure of the single eye, this is the portion which will get sheared out. Now single eye will be subject to the double shear, this portion and bottom portion. Now what will be the area of shear? That is area of shear, that is this thickness into, okay, now this is the thickness for the single eye, that is thickness into, this is the portion, okay, capital D minus dp, capital D minus dp. Now we are taking a radial portion only on this side, okay, divided by 2, okay, then it is multiplied by 2 because two different double shear is there, therefore it is equal to 2, that is D minus dp divided by 2, only this is the portion into T is the thickness and two areas are there, first area and second area, therefore tau will be equal to the P divided by D minus dp into T. Now sigma T and tau both the formulae will give the same right hand side. Now sigma T is equal to the SYT by Fs, tau is equal to the 0.577 SYT by Fs. Now from this we can calculate the different dimensions, different unknown parameters. Now next one, that is the failure of the double eye in tension. Now how the double eye will fail in tension? Now the tensile stress in double eye, now this is the portion, this is the cut section where the double eye will fail in tension. Now how it is there? Outside diameter minus inside diameter. Outside diameter is D, inside diameter is dp, and T1 is the thickness, that is D minus dp divided by 2 into T1 into 2 into 2. This is for one eye, then this is for second eye, this is for the second eye. Therefore you will get a total formula, that is sigma T is equal to the P divided by 2 into D minus dp into T1. Now value of sigma T should be, this is the induced stress in the component, this value should be less than the sigma T permissible. Then next one, that is the failure of a double eye in shear. Failure of a double eye in shear. Now this double eye will fail in the shearing, there will be the shearing failure. Now it will fail in double shear. Now how it will be double shear? That is it will have two portions will be available for the double shear. Now area of shear will be D minus dp divided by 2 into T1 is the thickness. Now double shear means into 2 and 2 forces are available, that means again it will become multiplied by 2. After simplification you will get the total formula, that is tau you will be equal to the P divided by 2 into d minus dp into t1. This is induced stress in the component. This should be less than or equal to tau allowable, that is equal to the 0.577 of SYT by Fs. Then next one, that is the failure of a double I in shear. That is a summary. That is the failure of a double I in shear. Double I will have subject to the two stresses, that is the tensile stress as well as shearing stress. We have developed the formula for sigma t is equal to the so and so, and tau is equal to same formula is there. Now sigma t is equal to the SYT by Fs and tau is equal to the 0.577 SYT by Fs, which will give the largest value that has to be selected. Then the last one, that is the failure of the knuckle pin in the bending. Now knuckle pin is being inserted into double I as well as the single I. Okay, and now if you have seen the diagram of knuckle pin, this 50% portion, okay, this 50% part is available in the single I. This portion is available in the one fork of a double I. This is the portion at the bottom which is available in the single I, and this is the portion available in the double I, as in case of a quarter joint that we have studied. Now suppose P is the force which is being available, T is the thickness for the single I, T1 is the thickness of a double I, and dP is the diameter. Now P is the amount of force which is being applied at the single I, therefore P by 2 is the magnitude available in the portion of a half of the portion of the single I. Now for this half of the portion, the magnitude of P by 2 will be applicable at the half of this distance. Now how much is this total distance? Total distance is T, half of the distance is T by 2, and again half of this distance, that will be equal to T by 4. Therefore half of the force, that is P by 2, will be applicable at the distance of T by 4. Now this uniformly varying load which is available in the portion of a double I. Now P by 2 force is applicable at the distance of h by 3 from the larger end, that is this larger end. Now how much is this distance? This distance is equal to T1. This distance is equal to T1. The force of P by 2 is applicable at the distance of T1 by 3 from the larger end. Therefore the total distance from the center point of P by 2, that will be equal to the T by 2 plus T1 by 3 is equal into P by 2. Now taking an equilibrium and making a summation of forces, then we'll get a formula, that is bending moment is equal to the P by 2 into T by 2 plus T1 by 3 minus P by 2 into T by 4. After simplification, you will get sigma b m is equal to the P by 2 into T by 4 plus T1 by 3. Now using a flexure formula, we know m by I is equal to sigma by y. Therefore sigma is equal to m into y divided by I, and finally you will get a formula of bending stress. This value of the bending stress should be less than the SYT by Fs. Now this is the last step in the design of our knuckle joint. Now all the steps are in combined. You should follow only these steps in the doing your practical as well as in examination. Now first of all, calculate the sigma t allowable and sigma c allowable. Now value of sigma t allowable is equal to SYT by Fs, sigma c allowable is equal to SYC by Fs, but SYT and SYC are same, therefore sigma t allowable is equal to sigma c allowable is equal to SYT by Fs, and tau allowable will be taken by using a maximum discharge energy theory, that will be equal to the 0.5 of SYT, 0.577 of SYT by Fs. Then evaluate the rod diameter, diameter of knuckle pin, thickness of single I, thickness of double I, outside diameter of single I, failure of a double I in tension, shear and bending is there. One thing you keep in mind, single I and double I both are subjected to the tensile failure, shear failure and crushing failure, and accordingly we can design the knuckle joint. Thank you.